Determine for the function f of x equals 3x squared plus 1 for x is less than or equal to 0, and 1 minus 2x for x is greater than 0 and less than 1, and x squared minus 3x plus 2 over x minus 1 for x is greater than 1, at each of the x coordinates x equals 0 and x equals 1, whether it is parts a through e. Each of the parts here involves the continuity of the function, so the first thing to do is write down the definition of what it means to be continuous. Limit as x approaches a from both sides of f of x equals f of a. Specific to this problem, we are looking at the x coordinates of 0. So we'll write this result down for 0. Limit as x approaches 0 from both sides of f of x equals f of 0. And limit as x approaches a 1 from both sides of f of x equals f of 1. We don't know whether either of these are true, so we put a question mark above each of them. But if they are true, these are the results needed to be continuous. Let's start with the limit as x approaches 0 from both sides of f of x. F of x here is a split expression function, and it is splitting at the x coordinate of 0, and therefore the two-sided limit will be determined by looking at the results of the two one-sided limits separately. So we'll have the left-sided limit of 0 for f of x, and the right-sided limit of 0 for f of x. Let's start with the left-sided limit. Left side of 0 means less than 0. From the split expression function up here, that means we will use that expression for f of x. So we can replace f of x with 3x squared plus 1. Next thing to do is try plugging a 0 in for each of the x's. That will give us 3 times 0 squared plus 1. And 0 squared is 0 times the 3 plus 1 will give us 0 plus 1, or just 1. Let's look at the right-sided limit of 0. The right side of 0 means greater than 0, and so up here we want to stay close to 0 because it is a limit, but greater than 0, so we will take that expression so we don't go bigger than 1. 1 minus 2x can replace f of x. Next thing to do is try plugging a 0 in for each of the x's, and we'll have 1 minus 2 times 0. 2 times 0 is 0, so 1 minus 0, and that comes out to a positive 1. The two-sided limit is determined by comparing the two one-sided limits. They do match, so our two-sided limit is also a 1. The other thing we need is f of 0, and that's determined by where x is equal to 0 in the split expression function, and that's here. It's including 0 at that one. We plug 0 in for that function. So we'll have 3 times 0 squared plus 1. Well, 0 squared is 0, so we have 3 times 0 plus 1. 3 times 0 is a 0 plus 1 comes out to a 1. So to recap, for the 0, we have the limit as x approaches 0 from the left of f of x does equal the limit as x approaches 0 from the right of f of x, and this does also equal f of 0, and therefore we have the exact situation to be continuous, and that one will be A. Now let's look at the two-sided limit as x approaches 1 of f of x. To determine the two-sided limit, we have a split expression function which is splitting right at the x-coordinate of 1, and we will once again have to work out the two one-sided limits separately. So we'll have the left-sided limit of 1 and the right-sided limit of 1. The left side limit of 1, left side of 1 means less than 1, but near 1. And that means we'll use that for the expression. So we can replace f of x with 1 minus 2x. Now we can try plugging a 1 in for each of the x's, and that'll give us 1 minus 2 times 1. negative 2 times 1 is a negative 2. 1 minus 2 comes out to negative 1. The right side of 1, we're greater than 1, and we can use this expression. We'll have limit as x approaches 1, the right side of x squared minus 3x plus 2 over x minus 1. First thing to do is try plugging a 1 in for each of the x's. That'll give us 1 squared minus 3 times 1 plus 2 over 1 minus 1. 1 squared is 1. Minus 3 times 1 is minus 3, and then plus 2 over 1 minus 1. 1 minus 3 is a negative 2, plus a 2 is a 0, and then 1 minus 1 is also a 0. We have the 0 over 0 indeterminate form, so we will have to rework this. These are power functions. The numerator is a trinomial quadratic, and it can be factored into x and x. And then we need two numbers to multiply to give a positive 2 and add to give a negative 3. Negative 2 and negative 1 will take care of that. And it is the x minus 1 factor that's making the 0 on both the numerator and denominator as x approaches 1. They can cancel. And now we can retry plugging a 1 in for the remaining x's, and that will give us 1 minus 2, which is a negative 1. The two-sided limit is determined by comparing the two one-sided limits. They match. Our two-sided limit here will be a negative 1. The other thing we want to determine is the f right at 1. So we look at the split expression function where the x-coordinate can be a 1, and, well, we don't include 1 up here anywhere. We have a less than 1 and we have a greater than 1, but we don't have an equals to 1. And that means the f of 1 simply does not exist. So to recap for the x-coordinate of 1, we have the limit as x approaches 1 from the left side of f of x does equal the limit as x approaches 1 from the right side of f of x, but these do not equal to f evaluated at 1, and that's the exact situation for being a removable discontinuity. And that'll be situation B, which is removable discontinuous at our x-coordinate of 1.